G'day guys. This morning I'm just going to go through five or six perimeter problems based on last video lesson. They're all a composition, so that means they're made up of multiple shapes, and they're mostly circles because it's usually the hardest one to calculate. So without further ado, we'll head into some of these circular problems. So I've posted these on my classes Google Classroom, 9NK, shout out. First problem we're going to do is this semicircle here. I want the perimeter of all these shapes. Perimeter. Alright, or circumference. Ooh. We want the perimeter circumference. So you could go ahead and pause the video if you haven't done these problems yet, and I'm about to go through them. So remember, the circumference of a circle is 2 pi times radius. I went through that in the last video. So if we want the perimeter of this thing, we're going to have to calculate the circumference. We're going to have to calculate this curved length around the outside, and we're going to have to add that length to this straight line here, this diameter. So notice that we've got half a circle. Well, that means we're only going to need half of the circumference. So if I was to half 2 pi r, if I was to divide that by 2, that 2 would just go away. So my length, let's say this is L, that's going to be equal to just pi times the radius. Okay? If you're year 10 or above, you could use your calculator. If you're in year 9, we're going to say that pi is approximately, so that's curved, it's just like a curved equal sign, is approximately 3. So L is 3 times the radius. Now be careful, because the radius was half that diameter, so it's 9. So that length is 27 meters. So the perimeter is going to be equal to 27 plus 18. So I'm going to get 15, 25, I'm going to get 45 meters. Hopefully that makes sense. The other way you could have done it would be that length is going to be the circumference divided by 2. So you could just go 2 pi r over 2 and actually just do it the long way. So 2 times 3 is 6 times the radius, that would be 54 over 2, which would give you 27 again. So you could have done it with the long way as well. Okay, let's do this one. So hopefully, yep, let's see all that on the camera. So now we have, this is a right angle, by the way, probably should have made that clearer, and that's 3 centimeters, so that's also 3 centimeters, even though it hasn't been drawn very well. And you can see when I've been tracing my 50 2mm panel pins, I've been tracing this, I've actually come off the side there. So 3/4 of a circumference system. So let's calculate the length L. L is going to be 3/4 times the circumference, which is 2 pi r. There's the circumference, and we want 3/4 of that. So 3/4 times 2 times, now on your calculator, on these graphics, once pi's down here, you have to go shift exp, and that gives you pi. There's pi. On these older, or on these scientific calculators, there we go, pi is also down there, so it's shift, and then we've got the times 10 to the power of x button is down there. So it's shift will give you anything in the yellow. So if you're using a calculator, you can do that. I'll show you on this one actually. So 2 times pi times, and the radius is 3. So we can actually do this in one big calc. So 3 divided by 4 times 2 times, I want to get pi in there. There we go. Times 3 for the radius. 14.14. We'll just go 0.1. One significant figure more. Oh, 1 dp. 1 dp for centimeters. That goes to the nearest millimeter. If you were just doing 3, that would be 3 divided by 4 times 2 times 3 times 3, 13.5 if you just used 3 for pi. So that's the length, and now we need to add that. So the perimeter is 14.1 plus that length plus that length. So that's 6, so that's going to be what, 20.1 centimeters. Remember your units. If you don't write these units in, you won't get the full marks. Okay. This one here, again, it's a half circle, but remember we have to figure out what that diameter is. And so this is meant to be a square, okay? So I was meant to have right angles there. And so this diameter is also 10. So what does that make the radius? Well, that makes the radius 5 centimeters. So we'll calculate, I just use a stylized L. I don't really mind what you use, but let's go L for the length of the curved surface. So I just like to separate the curved surface because it has a little bit more calculation to it. And that's going to be a half of circumference, and circumference is 2 pi r. So we go a half times 2 times 3 for pi, just because it's nice and easy. If you're in year 9, you'd use a 3 times the radius, which is 5. So that's going to be 15 centimeters. How do I do that without a calculator so quickly? So I noticed that a half times 2 is 1, so that's all gone. I've just got 3 times 5. And so the perimeter is 15 plus 8 plus 10 plus 8. And so we've got 15 and 8 is 23, 33, and 8 takes us to 41. And I have my units there. Pretty easy stuff. All right, once you know that formula for circumference and you understand how to get the fraction of it, then you're away. All right, some harder problems now. All right, hopefully that's lining up on the camera, all good. So what we have here is, hopefully you can see that, is we have a 3/4 circle and we have a quarter circle that's a little smaller. So what we want to calculate is, we'll go capital L for that big length, and we'll go little l for that length. So big L, we want 3/4 of a circle that has radius 15. So 3/4 times 2 times pi times that radius 15. And I'll alternate between using a calculator and just using 3. So 3 divided by 4 times 2 times pi times 15. You can actually just do that all in one big calc, right? Bed mass isn't very important here. 3/4 times 2 times pi times 15. We get 70.7. Little l, well, that's going to be 1/4 of a circle with radius 9. So that's 1/4 times 2 times pi times 9. Okay, so that's 1/4 times 2 times pi times 9, and that's 14.1. All right, so we could add those together, right? And you'd think we're done. However, we need those two straight edges there. So remember that entire length from the center to the outside is 15. And from here to there is, from the center to the outside, a smaller one is 9. And so the leftover must be 6. So our perimeter is 70.7 plus 14.1 plus 2 lots of 6, there's 2 of them there, 12, and I'm going to use a calculator for that one. 70.7 plus 14.1 plus 12, and that gives us 96.8, and the units are centimeters. Okay. This problem here is what's the quicker path to get from A to B? You guys could give that one a go. So the total length from A to B is 8. All right, so let's do big L again for the big arch. What is big L? Big L is going to be a half the circumference of a circle. So it's half times 2 times pi times, you don't actually need the multiplication symbol when it's 2 times pi, that you could just do this. But I'm just making it really clear we're multiplying through there because this is an introduction to circumference of a circle. And what's the radius going to be? Well, it's going to be half of that diameter. Remember, we've got the diameter is from one side to the other. So half of that is 4. So I should have about 12 centimeters if I use pi as 3. If pi is 3, remember, half times 2 is 1. And then I've got 3 times 4 is 12. Okay. What about for this one here? So one of these, so let's go lil L. So lil L is going to be a half a circle times 2 times pi times the radius. Now the radius of this thing is a half of 8 and then a half of that again, right? We've got a quarter of 8 times 2. So that path would be 2 times pi, and in this case we've used pi as 3, 6 centimeters, but we've got 2 little L's. So total length of both paths is 12 centimeters. So in fact, that is the same as that. So if you were to walk both of those paths at the same speed, you get there about in the same amount of time, which is really interesting. It's not that intuitive by looking at that picture. Looks like that path would be a lot longer, but I guess this big arching path would take some time to cover. I've got one extra problem that I'm going to go through beneath here. So all you know, so this is based on like shipping logs overseas. So hopefully you can see all that. And what they do is they get these logs and they put them into some sort of pyramid like this. So this is just a cross section. And then they have a big metal band that goes around and they tighten that up just to keep these logs all in a tight bundle for easy shipping. What I've said is I've said that the logs are about 1/2 meter across in diameter. Okay. And what I want to know is what is the length of that metal band going around the outside? What is the length of that red band, given that these logs are 50 centimeters in diameter? So pause the video, give that a go. You should really try and do this one. If you get stuck, just try it again. Try it a couple of times. It's got a unique problem. I'm going to go through the answers for this right now. So what you might notice is that this band has to do a full circle, doesn't it? And so at these points here, this band is going off in a straight line tangent to the circle at that point. Okay, so if it went from here, it goes here to here. Okay, so notice if I put this line back onto this original circle and put it there, notice how I can do something very similar for this one. So obviously not drawn particularly well, but I can take those points and put them there. So the curved part of this metal band, this curved part is actually a full circle. So let's go curved length. I always like to communicate what I'm calculating. Well, that's a full circle and it would have a radius of 25 centimeters. So the curved part, so this part here, plus this part here, plus this part here would make a whole circle, wouldn't it? So that length is going to be 2 pi r. So that length is 2 times pi times a radius of 25 centimeters. So if I was to get my calculator out, calculate that, 2 pi, notice I didn't need to do the multiplication there, I do for the 25 though, times 25, 157.1, and that's in centimeters. Okay, so what's left over? What's the length of these straight parts? Well, because these are all in a straight line, okay, then this is coming off tangent, it's coming off straight and going across here, then what we're missing is we are calculating one radius, two radiuses, and then another radius. Okay, as that's the length of that line. So we have 2, 4, 6 of these radiuses. So let's go, these are longer, so I'll call them big L again. So big L is actually 6 times the radius 25. 6 times 25, 150. Should have known that off the top of my head actually. 150 centimeters. And now there's 3 of them. 3 of those. So the total length around the outside is 157.1 plus 3 lots of 150. 3 lots of 150 is 450 and 157. So we've got what, 607.1 centimeters around the outside. That's a nifty little problem actually. Cool. So that is the end of our perimeter circumference work that we've covered this week. Next week we'll be getting stuck into some area and then getting into volume after that. So just to reiterate what we did today, went through some compound perimeter circumference problems. There they are there. And then we had a quick look at how we could logically solve for the length of that metal band around those logs. There'll probably be another way of doing that. Comment down below. Cheers guys.